So to create a mathematical model in Python for a similar problem that will work in all similar problems, not just the numbers that we've inputted for this particular one, we need to restate the question. And if you remember from the last tutorial, there was a good reason for that. And that's because we deal with knowns and unknowns. And in real life, we would know what the coefficient of friction was, but we wouldn't actually know the tension force. We wouldn't actually know the reaction force. So as we're dealing with real life modeling, we have to restate that question that is more realistic. So question restated is this. A string is attached to a block of mass 4 kilograms, which is fine, we'll know that, resting in limiting equilibrium on a rough horizontal table with coefficient of friction 0.986. The string makes an angle of 24 above the horizontal. Find the tension in the string. So as I said, it's more restated to a real life situation. So nothing really changes. We still resolve vertically and horizontally. So we can see from the resolving, R is equal to mg minus t sine 24. And we talked about that in the previous example. And if we resolve horizontally, we've got similarly, so t cosine 24 is equal to mu r. So at this point, nothing's really changed. You know, the equations are still the same. It's just what we know is different. So this is the simultaneous equation form of that. And what's interesting is that we've had to put this r and t are unknown. So they're things we're trying to solve. So this is more like a sort of 1x plus sine 24y is equal to, in this case, would be 40 because that was m times g. And then similarly, this would be mu x minus, so we already know, so cosine 24t. So that would be our y in this case is equal to 0. So these are simultaneous equations. I've just realized that looks like a y rather than 24. So let's quickly correct that. The sine of 24y. So think of it like that. That's what we're trying to solve. We have to write it in that form in order to program this into Python. This was the code for our last tutorial in mechanics, where we dealt with a very simple problem where just one resolving. We did have friction involved, but we didn't have any external force. So it's quite a simple routine. We needed just 3 inputs and a calculation of the frictional force and the resultant force. Now, we've got a bit more going on in this next example, which I'm going to show here. This is the code for the more extended version of what we're trying to do. So we're extending the capability to deal with tension at an angle. So in the previous tutorial where I talked about simultaneous equations, I already talked about NumPy. So do look back on that video where I explain a bit more why you have to import that. What you also need to do is you need to import sine and cosine from the math database. Now, the reason for that is if you don't do that, then Python will just look at that in terms of individual characters, so SIN, but it doesn't mean anything. But if you import it from maths, they'll go, sin, that means sine. COS, that means cosine. So that's what you need to do. Now, in terms of the knowns, so the 3 components of mathematical modeling is knowns, the calculation, and the output. We know mass, we know gravity, and we know coefficient of friction. But we also know the angle of applied tension, which I'm calling Tn, so tension angle. We then move on to the calculation phase. And like I did in the problem, the first thing I did was resolve the tension. So between the horizontal and the vertical. So RV, so resolve horizontal, vertical, RH, resolve horizontal. And I've just done the sine and cosine part. Now, the main thing is this array. Now, let's talk about that a bit more. When we restated the question, we wrote it in terms of as 2 simultaneous equations, and they were this. So it was R plus T and sine 24, because we know the angle, was equal to the weight, which was mg, so 4 times 10, which is 40. And we also had a second simultaneous equation, which was mu r, because that's the frictional force, but then it was minus t cosine 24 is equal to 0. So you can see here 2 equations, 2 unknowns. And we also talked about it, in order for Python to be able to solve it, we had to restate it in a matrix form, which was this. So in this case, our coefficient was 1. So 1 times r is r. And then here would be sine 24. And then here would be mu. And here would be minus cosine 24. And our two unknowns, x and y, but in our case, it's going to be r and t. And if you recall from the last video, 1 times r is r, sine times 24 is t, and mu times r and minus cosine 24t. And this will give us our final answer, which is 40 and 0. Now, let's match the coefficients. So this here is here. RV, which we said was sine t angle, is here. Mu, which is this, because mu is our coefficient of friction, and minus RH, our resolved horizontal force, which is here. And this part here solves this. Now, when you actually output this, so from the solving point of view, it will come in this form. And so our value of r, and our value of t. And what this routine here does is that it just extracts an appropriate column. So column 0, column 1, and S is the matrix we have. So then here we've got that extracts the value of r and extracts the value of t. So we have them separate, which is actually more useful, particularly if we're going to feed it into more complicated calculations, which we'll do down the line. And then finally, print. And I want to round it, so I've rounded it to 2 decimal places rather than being like a million decimal places or whatever, however many it is. Now, running the code gives us the following answer. Tension as 30 and reaction force is 27.79. And we've used the values in the question. Mass was 4, gravity was 10, coefficient of friction 0.986. And I want to talk about this a bit more, the angle of applied tension, where you might be thinking, well, hang on a minute, the angle was 24 degrees, and you'd be correct. However, this is a different unit of measurement of angles, and this is called radians. I'll go into that in another video. Basically, Python trig functions use radians rather than degrees. So this is equivalent to 24 degrees. And yeah, our code works, and we can certainly test that with different values of mass, different values of gravity, coefficient of friction, and so on, which is pretty neat. We've shown that it's now versatile and work in any situation involving the angled tension force. So next week, we're going to extend our coding capability and deal with inclined planes. Make sure you rate, comment, and subscribe, and I'll see you on the next one.